Latin square design. The design of the Latin square must be set up in a way that the information that needs to be derived can be accurately calculated. The arrangement of independent variables must be unique to a column and a row. The Latin square design, it will reduce the effect of geography. So if there's one independent variable used, we'd actually use a one-way ANOVA analysis. So a Latin square design is traditionally used in agriculture to determine what factors affect the positive outcome. The results of these Latin square experiments have aided individuals and companies to identify what conditions and independent variables produce the optimal result. The same Latin square designs can identify what common causes may yield an undesirable result. So, in our example we're looking at planting on a land with varying geography. So we're going to be planting cash crops and applying 4 different brands of fertilizers. So what will be the dependent variable? That will be the quantity of produce, which is produced, or the yield. And what will be our independent variables? This will simply be fertilizer A, B, C, and D. And since we have one type of independent variable, we'll be using a one-way ANOVA analysis. Now we're going to be looking at how the land is structured. Say we have one piece of land, looks like a rectangle. We break it up into quadrants. So we have, I'll call this one quadrant A, B, C, and D. All right, suppose we go ahead, and this is definitely not a Latin square design. Right now we look at A, we look in the row, we have another A, definitely not it, not independent. We look at A is right below it in the column, so that is not a Latin square design. So how do we go ahead and arrange it? Let's go ahead and put it in a Latin square format. We'll look here, we have A, and it is independent to the row. We have A, it is independent to this column, it's unique. But we also have to take in consideration the landmass, or at least we'll look at the geography. We'll look at this section in this quadrant. We have a lot of shades, a lot of trees are here. So we're going to say, we notice that we have D repeating. So to get the optimal result and to get all 4 different type fertilizers in that land, we'd have to optimize the entire Latin square design. And see right here with the shaded region, the quadrant, with the trees, we now have A, B, C, and D. In the sandy soil, we definitely have A, B, C, and D. So now it takes into account the different types of fertilizers that are on all different types of geography. And that's how we find the optimal yield by using the Latin square design.